So here P of the Ik is equal to 1 and P of Kj is equal to 1. Then I will say that P of Ij is also equal to 1. Okay. And one more change here I have done. So diagonal element I have written it as a 0. So diagonal elements will not be 0. Why means 1 to 1 there is a path from 1 to 3, 3 to 2, 2 to 1. So diagonal elements will also become 1 when I will apply this particular algorithm. Again 2 to 2, 2 to 1, 1 to 3, 3 to 2. I can come back. Same thing for this also. 3 to 2, 2 to 1 and 1 to 3. So here what we are doing in this particular algorithm, just we are checking that if the direct edge is not there, can I have edge through some other vertex k? If there is a path, then I am taking P of Ij is equal to 1. So when I will take that, obviously the diagonal elements will also become an 1. So this is an algorithm. You can go through it. Is very simple algorithm. Tracing I will explain you. So this is an algorithm. Just it is very simple. 3 for loops. Check that if the direct edge is 0. If direct edge is 0, through k are you having a path? If the path is there, then P of Ij will become 1. If this is also false, means anyhow this will be an 0 only. No need of updating that one. So this is an algorithm. Then come to the analysis. Analysis is clearly given in my notes. You go through the analysis of this particular algorithm. Obviously you can say what is an time complexity of this algorithm. What it is? It is n cube. Why? How many for loops you are having? 3 for loops are there. One is k is equal to an either 0 to n minus 1 or 1 to n minus 1. It doesn't matter. How many times the inner instruction will be executed? 1. And already many times we solved this one. When I'll solve this one, I'll get to the time complexity as an n cube. So that is the time complexity of your Warshall algorithm. It is n cube. Even though you are going through the matrix, it is not n square. Why? It is n cube. There are 3 for loops you are using. One for k, one for I and one for j. Therefore, the time complexity of your Warshall algorithm is n cube. And all of you know that how to solve this one. So that is about the analysis or a time complexity of an Warshall algorithm. So next we will see the tracing for the Warshall. Let us consider this particular graph. Something like this. Diagonal elements will be, what I am writing? I am writing the adjacency matrix, not the path matrix. Path matrix we will find out. Okay. So 1 to 2 path is there, 1 to 3 no path, 1 to 4 no path, and 2 to 1 no path, 2 to 2 0, 2 to 3 no path, 2 to 4 1, 3 to 1 path is there, 3 to 2 no path, 3 to 3 0 diagonal element, 3 to 4 no path, and 4 only to the 3 path is there and to the 1 path is there, remaining 2 are 0. So this is an adjacency matrix what you have wrote. So after that one what you have to do? Through 1. What is that k? K can be an 1, k can be 2, k can be 3, k can be 4. So what is that algorithm I wrote? P of Ik is equal to 1 and P of Kj is equal to 1. Then I will write the P of Ij is equal to 1. That is what I am doing now. Initially k is what? Through vertex 1. Next iteration through the vertex 2. Next iteration through the vertex 3. Next iteration through the vertex 4. Same algorithm only I am tracing. Initially, what is my k value? 1. I am not starting with 0, I am starting with a 1. Then 2, then 3, then 4. That is what we will do now. So, first when k is equal to 1, through vertex 1. I'll consider this row and this column. I'll consider this row or leave this one. You can consider only this. Through the first row and first column. Through 1. Through vertex 1. Through vertex 1. Okay. Take the first row and the first column. Wherever in the column entry 1 is there, you take this and repeat it for the ones in the rows. Okay. Getting my point? Take the ones in the column. Repeat that one for every one in the row. So take this one in the column. What is this is called? That is since. What is that? Yeah, this is an A of ij if I'll take. So if A of, what is this? 3 to 1. 3 to 1 is equal to 1. This one I am taking. 3 to 1 is equal to 1. This I am taking with this one. What is that one? And A of this 1 is nothing but 1 to 2 is equal to 1. So there is a path from 3 to 1 and 1 to 2. So obviously there will be a path from 3 to 2 will become 1. Then 3 to 1 will become an 1. So I am taken this one, repeated with this one. So this 1 is means what? 3 to 1 is equal to 1. This one means 1 to 2 is equal to 1. If there is a path from 3 to 1 and 1 to 2, obviously there will be a path from 3 to 2 will be equal to 1. So now are you having any other ones in the row? No. Stop there. Then take the one more one in the column. What is this one represent? So it is since A of 4 to 1 is equal to 1 and repeat this one with this row 1. What is that row 1 represent? It is 1 to 2 is equal to 1. If there is a path from 4 to 1 and 1 to 2, then I'll say that there is a path from 4 to 2. 4 to 2 will become 1. So that's it. There is no more changes can occur through 1. So write down that new resultant relation. Resultant matrix. So which will be get 3 to 2 is 1. 3 to 2 1. 4 to 2 1. 3 to 2 1. 4 to 2 1. Rest all will be same. 0 1 0 0. 0 0 0 1. 1. This is 1 0 0. Then 1. This is 1 1 0. So this is the resultant matrix what we got after through 1. Okay, after through 1, this is the resultant matrix what we got. Next I consider the second row and second column. Through 2. It is through 2. Through 2. Through 2. Okay, when I will take that one, so here I will take first column 1, which is column 1, this one. This one means what? It is since A of 1 to 2 is equal to 1 and this one I will repeat with the row 1. Which is the row? This is the row. Which is row 1? This one. This one means what? A of 2 to 4 is equal to 1. Therefore, I can write A of 1 to 2 is equal to 1, 2 to 4 is equal to 1. I can write 1 to 4 is equal to 1. Okay. So, this one I have repeated with this one. No more ones are there in the row. Over it is. Now, take the one more one in the same column. Now, this one you repeat with this one. Okay. Column 1 has to be repeated with a row 1. This one means what? So, it is A of 3 2 is equal to 1 and A of 2 4 is equal to 1. So, there is a path from 3 to 2 and 2 to 4. Therefore, I can write A of 3 to 4 is equal to 1. Now, this is over. This one you repeat with this one. So, this one means what? Since there is a path from 4 to 2 is equal to 1 and A of 2 to 4 is equal to 1. Therefore, I can write the A of 4 to 4 is equal to 1. So no more ones are there, you can stop. So these are the changes through 2, after through 2. So which we have changed? 1 to 4, 1, 3 to 4, 1, 4 to 4, 1. Remaining elements you write as it is. Means the previous one. Not this one. Previous one. Okay. See here what I told, dynamic programming concept. I'll take one instance of the problem, solve it, store it in a table, use this table resultant whatever you are having in the table for solving the next instance. First instance is through 1, second instance is through 2. So for solving the next instance through 2, I am using the result of the instance that is then through 1. So again now in order to solve through 3, next instance, I am using the result of the previous instance, that is through 2. Means I am using this one for solving the next instance. What is your next instance? Next instance is nothing but the through 3. So through 3. 1, 2, 3, 4. 1, 2, 3, 4. Through 3 means take this third column and third row. Third column and third row. How many ones you are having? Only one is there. So repeat this one with all 3 ones which is there in the row. This 1 means what it is? A of 4 to 1, 4 to 3 is equal to 1. 4 to 3 is equal to 1, and 1 you repeat with this one. This one means A of the 3 to 1 is equal to 1. So there is a path from A of 4 to 1 will be equal to 1. Again you repeat this one with the one more one is there in the row. Okay, this you repeat with a one more one. So this means what? That is 4 to 3 is equal to 1, and the A of this one means what? 3 2 is equal to 1. So there is a path from 4 to 2 is equal to 1. Again you repeat that same one with this one. One more one is there. And what is that one? A of 3 4 is equal to 1. Therefore A of 4 to 4 is equal to 1. Okay. Now what are the changes you have done? No more ones are there. You can stop here. Whatever the changes you have done, 4 to 1. 4 to 1 is 1. Then 4 to 2 is equal to 1. 4 to 4 is equal to 1. Okay, I think already we have written all. Rest all the things you write as it is. Okay, done. So this is through 3. There is no change here. Through 3 there is no change, but it doesn't matter. It may get changed, it may not get changed. Okay. That is about the through 3. Through 3. There was no path from 4 to 1. Huh? Already we have got it through 2. 4 to 1. Okay, this is the path matrix what you got through 3. Next I will do for through 4. Through 4. It is a lengthy problem. Okay, whenever you are having a R choice in the final exam, then don't suddenly take this particular problem because it takes too much of a time. Instead of this dynamic programming, if any other choices are there, you can go for that. But if that entire module 4 itself is a dynamic programming concept, so all problems are like this only. But while selecting the problem, you take and select. And if you are having in this one knapsack problem in one choice and Warshall in another choice, go for the Warshall, don't go for the knapsack problem, like that. So whichever is convenient for you, you take that particular problem, because all the problems under dynamic programming, it will take time. So what is through 4? Take this. Oh, this takes too much of time now. Okay. Now repeat this 1 with this one. So this 1 means what? It is 1 to 4 is equal to 1, and this 1 with this one means it is 4 to 1. 4 to 1 is equal to 1. Therefore, there will be a path from 1 to 1 will be equal to 1. Okay. So next, I'll repeat this 1 with this one. This 1 means 4 to 1, and this one means 4 to 2. 4 to 2 is equal to 1. Therefore, 1 to 2 will be equal to 1. 1 to 2 will be equal to 1. Again, I'll repeat this 1 with this one. This 1 means 1 to 4 is equal to 1. This one means 4 to 3. 4 to 3 is equal to 1. Therefore, there will be a path from 1 to 3. 1 to 3 is also equal. 1 to 3 will be 1. Therefore, I have entered here as a 1. Next, I will take this one, same one with this one. This one means 1 to 4 is equal to 1. This one means 4 to 4 is equal to 1. Okay, then there will be a path from 1 to 4 will be equal to 1. 1 to 4 is equal to 1. So that is just what I have done. This 1 I have repeated with all these 1. Next, what is one more 1 in the column? The one more 1 in the column is this. Again, I need to repeat this with all these 4 ones. So what is that one? 1 is nothing but it is 3 to 4 is equal to 1. This I am repeating with this. Means it is 4 to 1 is equal to 1. Therefore, there will be a path from 3 to 1 is equal to 1. 3 to 1 is equal to 1. Okay. Now again I will repeat this one with this one. What is this one? 3 to 4 is equal to 1. What is this one? 4 to 2 is equal to 1. So there will be a path from 3 to 2. 3 to 2. 3 to 2 will be 1. Okay. Now again I will repeat this one with this one. This one means 3 to 4. This one means 4 to 3. Okay. Then therefore there will be a path from 3 to 3 will become 1. 3 to 3 will be 1. Okay. Next again I will repeat this one with this one. This one means 3 to 4. This one means 4 to 4. So there will be a path from 3 to 4 will become 1. So 3 to 4 will become 1. Now I have repeated this one with all the 4 1. Now this one I have to repeat with all these 4 1. So what is that 4? That 1. This 1 is nothing but 4 to 4 is equal to 1. And this one I have to repeat with this. This means 4 to 1 is equal to 1. So there will be a path from 4 to 1. 4 to 1 will be equal to 4 to 1 will be equal to 1. Next I will repeat with this with this. This means which one? It is 4 to 2. So there is a path from 4 to 2. Again I will repeat this one with this one. So what is this one? 4 to 3. So it is 4 to 3. Again the same thing will be 1. So write the second one as it is. Okay, sorry, there is one mistake while copying. This is 0, 0, 0, 1, 2 to 4, there is a path. So this is 1, it is not 0. Okay. This is 1 means where I will get change now. This is through 2. So when I am doing through 2, it is, I have taken this. Where after changes I have done or not? I think that is correct. Okay, through 4 when I will go, this will become 1. Again this 1 I have to repeat it with all the 1s. This I have taken it as a 0. It is actually the 1. Same thing need to be copied here. So this 1 has to be repeated with all this 1 means what? This 1 is which one? 4 to 2 to 4. 2 to 4 is equal to 1. This you repeat with this. This means what? 4 to 1 is equal to 1. Therefore, there will be a path from 2 to 1 is equal to 1. So, this is not 0, this is 1. The mistake was I have not copied this 1, I have copied it as a 0. That was the mistake. Again, I will repeat this one with this one. So, this one means 4 to 2. Therefore 2 to 2 will be 1. Then I'll repeat this one with this one. This one means 4 to 3. So 2 to 3 will be 1. Again it is this one, I'll repeat with this one. 4 to 4. 2 to 4 will be 1. So finally this is the path matrix. What we are getting means from every vertex there is a path to the any other vertex, like this. 1 to 1, like this I can move. 1 to 2 I can move like this, and 1 to 3 I can move like this. 1 to 4 I can move like this. Okay, same thing. 2 to 1 I can move like this. 2 to 2 I can move like this. 2 to 3 I can move like this. 2 to 4 I can move like this, and 3 to 1 like this. 3 to 2 like this. 3 to 4 like this. 3 to 3 is like this. 4 to 1 like this. 4 to 2 is like this or like this, and 4 to 3 like this, and 4 to 4 like this. So from every vertex I can move to the any other vertex. That's why all the final entries are 1. If I am not having path for one vertex or another, obviously one of or two of them will be an 0. So this is the adjacency matrix, and this is a corresponding path matrix, or this we will also call it as a transitive closure. When they'll ask the question, they may ask you write the transitive closure for a given graph. Don't get confusion. Both path matrix, transitive closure are nothing but the Warshall's algorithm only. Both the transitive closure as well as the path matrix, they are represents the Warshall algorithm, which comes under this dynamic programming concept. So that is about the algorithm analysis and the tracing. And usually one more thing, tracing when they are giving, they will give only for the 4 vertices, not 5 vertices, because it takes too much of time. So usually they will end up with the 4 vertices only. Okay. And come to your lab program. Lab program is very similar to your algorithm only. Only that 3 for loops and 1 statement. That's it. Nothing else is there. So you can go through that one. I think no need of explaining that particular program. Okay. Thank you.